Welcome to another exciting educational video brought to you by Upvision Concepts Academy. So in this video, we'll be looking at calculations on simple machine. We'll be crystallizing all calculations from NECO, WAEC, JAMB that is related to simple machines. So this promises to be an exciting video. Sit tight and subscribe if you're not subscribed, and we'll enjoy the video. Straight up, the first question on the board is saying a pulley system has a velocity ratio of 6 and lifts 800 Newton through 1 meter with 50% efficiency. Find the effort. So we are given that velocity ratio is 6. Okay, we're also given that load L is 800 Newton. Okay, we're also given that load distance is 1 meter. Load distance is 1 meter. That we're given efficiency, sometimes expressed as this, is given as 50%. Okay, and we are to find the effort. Okay, now we also know that efficiency is given as mechanical advantage MA over velocity ratio VR times 100 over 1. Okay, so efficiency is given as mechanical advantage over velocity ratio times 100 over 1. Okay, so I'll quickly get the mechanical advantage. Okay, I'll get it. We're given that efficiency is 50% from the question. 50% is equals to MA unknown all over VR velocity ratio is 6 times 100 over 1. So I can get this quickly as saying 50 times 6 over 100 will give me MA. Now what is MA from here? MA will be given as 3. MA is 3. Why? Because this cancels this, and this time this is 30. So MA is 3. Now if I have MA as 3, my goal is to find the effort. We know that mechanical advantage is equals to load over effort. Okay, and then the load is already given as 800, so I'll just plug in 3 is equals to 800 over effort. Okay, so this one would multiply this, so I have effort is equals to 800 over 3. So by the time I do the computation maybe by calculator, I will see that the effort in newtons is 266.67 newtons. 266.67 newtons. That's the answer for the effort. So we'll go on to the next question. Okay, so we have the next question on the board. This question is actually from JAMB 1999. The question 1 we just solved is from JAMB 2010. Okay, so it said that a weight W is in equilibrium with 40 Newton via a frictionless pulley. What is W? So actually it looks like something like this. A weight W is in equilibrium. It's a pulley. Sorry. This is a pulley. So this is the weight, and this is 40 Newton. So they said the weight is in equilibrium with this one. The weight W is in equilibrium with a 40 Newton via a frictionless equilibrium. Sorry, a frictionless pulley. So there's no force here that is adding to this system. So this is a very classic case of saying that this one W is equals to 40 Newton. Very simple. Very simple. You know, in a simple frictionless ideal pulley system, this 40 Newton weight is balancing another weight, that's W, unknown. And the pulley has no friction. You understand? Then for equilibrium, this and this, they are equal. So that's the answer. Quite tricky, but straightforward. Okay, so we have this question on the board. It says a heavy barrel rolls up a 30-degree incline plane. What is the velocity ratio? So for inclined plane, velocity ratio is given as 1 over sine theta. So sine theta is 30 degrees, right? So 1 over sine 30 is the same thing as 1 over 0.5, and VR, which is velocity ratio, is equals to 2. That's the answer. Okay, so we have a question on the board. It says a block and tackle pulley has 40% efficiency and supports 120 Newton load. Find the effort. So efficiency can also be expressed as the ratio of work output over work input times 100 over 1 in percentage. And the work output has to do with the load times the distance moved by load, and work input is the effort times distance moved by effort. And efficiency is given as what? 40%. So this point, the load is 120 and the effort is not given. Assume that they both move the same system, a block and tackle pulley system. They both move the same distance. Okay, so I can now find effort by making each of the formula. So here, if you cancel this, have yeah, 120 times 10 over 40 over 4, sorry. So effort is 300 Newton. Effort is 300 Newton. So if we check, you can check that the ratio between this and this will give us 40%. Okay, the next question. Okay, so we have another question on the board, number 5. It says a machine with velocity ratio 6 requires 400 Newton to lift 800 Newton. Find its efficiency. Efficiency is given as mechanical advantage over velocity ratio times 100 over 1. But we are given velocity ratio already at 6. Okay, so VR is 6. We are given requires this to lift this. So this amount is the effort. The effort is 400 Newton, and the load L, effort E, and load L is 800 Newton. So mechanical advantage is load over effort, which is 800 over 400 will give me 2. MA is 2. If MA is 2, if I put it here, I have MA is 2 over VR is 6 times 100 over 1. So I can get mechanical efficiency. 2 year 1, 2 year 3, 3 year 1, 3 year 33.333. So efficiency is 33.33%. That's the answer. Okay, so we will go on to elasticity on this video. Elasticity. I have a question on the board. It says a spring extends from 10.0 cm to 10.01 cm under this force. Find the force constant. So this is under Hooke's law. This is how we do it. So this is a weight that applies. The weight is actually 20 Newton. And when it was applied the first time, this experiment actually, you have a calibrated metal rule here. Of course, we are trying to read up the values. So there was a point where it was like this. Then when this was added, it will extend. So it will extend. So there's a difference between the weight, or the length. The first time, without the weight, without this weight, it was 10 cm, 10.0 cm, and with the weight, it became 10.01 cm. So there was an extension. So there's a difference. There's a change in length, change in length. Okay. Okay, so initial length of the spring from here, initial length of the spring, initial length is 10.0 cm. Final length is 10.01 cm. Change in length is equals to 10.0 minus, sorry, 10.01 minus 10.0. The change in length will give us 0.01 cm, but we need to convert it to SI. So how many meters, centimeter equal meter, that's 100. So I'm going to multiply this by, divide it by 100, I beg your pardon. So I'm getting 0.0001 meter, yeah? 0.0001 meter, and the applied force, F, is 20. Now, Hooke's law states that the force F is directly proportional to the change in length, provided K is constant. That K is what we're looking for. That is the elasticity limit. We have the applied force as 20 Newton. So I can make K substitute the formula. K is equals to F over change in length. And K is equals to F, which is 20, over 0.0001. And K will give me a very big value, 200,000 Newton per meter. That's the units. 200 Newton per meter. Okay, we'll go to the next question. Okay, so I have this question on the board. It says a spring 0.2 meter with this load, 0.3 kilogram, and again on that instance I have 0.3 meters with 1.95 kilogram load. Find K and LO. K is the Hooke's constant, Hooke's constant, or the constant of proportionality, and LO is the initial length. Okay, you know we are operating under Hooke's law environment, and we're told we know that the force is equals to K L minus LO. So there are two instances I have here. At the first instance, with this load, the extension, the spring became this. So the spring got to this final length with this load. And the second instance, the spring got to this length with this load. Mind you, these are weights and they are not, they are mass in gram and they're not load yet. So I'm going to convert it to load by multiplying by gravity, due to gravity. Okay, so having known this, LO is not initial length or natural length, all right? So having known this, I'm going to be writing out the equation. So for the equation, for the first one, I would say for 0.3 kg, I will convert it to weights by saying 0.3 times 9.8 meter per second. So this will give me, by way of punching my calculator, I'll be having 2.94 newtons. Okay, so, and for the position, 1.95 kg, converting it to mass, not mass, to weight, 9.8, I'll be getting 19.11 Newton. Now I have gotten these two as weight or force. So I'm going to be writing equation for these two here. So for this first force, for this first instance, when a 2.94 Newton was applied, I will write the equation. For the first instance, I will call it equation 1. First instance is equation 1. So I'm going to say 2.94 is equals to K is unknown into L. L is the final length. Final length is 0.2 meter minus LO, which is initial length, natural length. Then I will write the second equation, number 2 equation. I will say 19.11 is equals to K constant, into final length is what? What's final length? 0.75 minus LO. So I have two equations. From here now onwards, it's mathematics. I'm told to find LO, initial length or original length, and K, the constant of proportionality. So like I said, from here on is mathematics. In office and maths are always together. So I'm going to come to this side of the board. I'll continue from there. I have two equations. So I'm going to subtract both sides. Subtract 2 from 1. 2 from 1. Let me just break it down like this. Okay, so subtract 1 from 2. Okay, I will still write 2 upstairs like this, and I will put equals to K 0.75, or I can multiply 0.75K minus KLO. That's equation 2, and they have 2.94 is equals to 0.2K, that is this time 0.2K minus K LO again, equation 1. So I'm going to be subtracting, so I'll just draw my line like this, put minus sign here. Okay, so by the time I do 19.11, 19.11 minus 2.94, I'll be getting 16.17 is equals to this and this. I'll be getting 0.55. K. So I can make K such a formula. K will now be 16.17 over 0.55. So K is equals to, the constant of proportionality is 29.4 Newton per meter. So I've gotten one of the parameters, K. So how do I get LO? I can put it in any of equation. Let me say substitute in equation 1. So this K, I'm going to be putting into equation 1. So equation 1 reads 2.94 is equals to, where I see K, I put 29.4, right? Open bracket 0.2 minus LO. So LO is the only thing that is different here. So again, mathematics, I'm still going to solve. I can decide to say divide this side by this side and multiply by subtract this. Okay, so I can do division. I can divide both sides by this. So I can say 2.94 over 29.4 is equals to 0.2 minus LO. So when this one happens, in fact, by the time you do everything, LO, this is mathematics, LO will give me 0.1 meters. 0.1 meters. 0.1 meter represents the initial length of this. So it is potential length 0.1. Then when 0.3 was added to it, it became 0.2. When 1.95 kg was added to it, it became 0.75. Okay, so we move on to the next question. Okay, so number 8, it says spring with K is equals to 500 Newton meter compressed by 5 cm. Find the energy stored. So energy stored formula is equals to half kx squared, where K is the extension or the difference in length. Okay, extension, either negative or positive extension. This one now is compression is negative extension because it's anti-extension. Compression is negative extension because it's anti-extension. But does it really matter? It doesn't really matter because extension is actually the compression or extension is actually a change in length, either positive or negative. So it doesn't matter. So, but then, what is x in this scenario? X is 5 cm or 0.05 meters. Okay, and we're given K we're given K as 500 Newton per meter. So just plug into the equation. E is equals to half times 500 times 0.05 times 0.05. So when we compute, we'll be getting 0.6 0.625 joules. 25 joules. So this is energy we're talking about. 0.625 joules. So the next question. Okay, so we have this question on the board. It says a 0.3 kg mass stretches spring from 0.2 to 0.75. So the extension is actually 0.75 minus 0.2. Find K and strain energy when unloaded extension is 0.1. So, well, unloaded extension actually has to do with natural length. This is natural length, right? Okay, so we're going to be looking for two things here. We're going to be finding K, and again we'll find the strain energy. So F is equals to formula. F is equals to Kx, right? Where F is the force that will require to extend this, and X is the extension. Okay, so now this particular F is the force produced by 0.30 kg. We're going to be converting this 0.30 kg to force. Converting 0.3 kg to force, we multiply 0.3 kg times 9.8 meter per second. Why? Because this is gravity. Understand? So the force we're going to be getting when we do the conversion is calculation, please. Okay, so we're going to be getting 2.98 Newton. So we've gotten this component. So 2.98 is equals to K is unknown, and the extension is the difference between the initial length and the final length. So extension is 0.75 minus 0.2. Okay, let me just put it in brackets here. 0.75 minus 0.2. That is just these two. This is initial length and final length, right? So K is equals to 2.98 all over difference between these two will give me 0.55. 0.55. So K, which we are looking for, the first thing we're looking for is, if I divide this by this, I'll be getting 4 points. Okay, so there's something that we did not take into cognizance. This unloaded extension, when unloaded extension is, so this is the initial length. This is the initial length. So we're going to be adding this. We're going to be subtracting. Okay, hold up. Maybe I want to get, there's a way we are going to use this term. Okay, so actually we're going to be checking the difference between this from the natural length, which is 0.1. 0.1 is natural length. Okay, so I have this as 0.65 here. So K is going to be giving us 2.98 divided by 0.65. 0.65 will give us 4.52 Newton per meter. Okay, so this is for K. Now, the next thing is to find the strain energy. Strain energy, E, is given as half Kx squared, half times K, which is 4.52 times x squared. X extension is 0.65 squared. Okay, so by the time we compute the math, we're going to be getting in joules 0.955 joules. So this is the K constant, and this is the strain energy rounded. Okay, so the next question. Okay, so we have a question on the board. It says 11 kg mass suspended by aluminium wire. L is 2 meters and diameter is 2 millimeters. Calculate the elastic energy. Young modulus of aluminium is 7 times 10 raised to the power 10 Pascal. So we have to find the elastic energy or the strain, is given by, I can call it U, is equals to F square L over 2AY. Okay, what all this means? F is force. It's force, right? Force, mass times gravity, which is also force applied. Okay, so L is the length, original length, that is L, original length. Then A is area, and Y is Young modulus, constant. Young modulus, that one is given. So we need to just find the area. Area, let's see how we can get the area. The area is actually the cross-sectional area. A is equals to pi r square, right? And pi is given as 23.142 times radius. This is a diameter, so change it to radius. That's 1. So it is 1. But it is in millimeter, change to meter, that's 0.001. 0.001, yes. 0.001 all square. That's pi r square, all right? Then this one will give me 3.1416 times 10 to the power minus 6. So this one is the area already, that's meter squared. So I can put it in this formula. Strain, U, not mu. Strain is equals to, the force is actually the 11 kg times 9.8. Yes, 11 kg times 9.8. To change that one to force, 11 kg times 9.8 will give me 110.7.8 all square. So what I'm having here is this force square, which is coming from here, times the length. The length is 2, right? All over 2 again here, times area, 3.1416 times 10 to the power minus 6, then times Young modulus. Young modulus is this long thing that is here. This is actually JAMB question. One of the JAMB questions. I think 20, let me confirm the year. This is, okay, so WAEC 2013 question. Okay, so let's continue. So it is the force square times 2, that's the length, over 2 in the formula times area, which I've gotten here, times Young modulus. By the time we complete all of this, the energy or strain will be given as in joules, approximately 0.053 joules. Okay, so in this video, we're able to combine two concepts, calculation on elasticity and calculation from simple machines. So check the comment section for more questions and even the description. And I hope this video has been informative for you. I'd like to thank you for viewing.